Hello class. In section 1.6, we're going to talk about the midpoint and distance in the coordinate plane. So we're going to start talking about a baseball field. Major League Baseball fields are laid out according to strict guidelines. Once you know those dimensions of a field, you can actually use a coordinate plane to find the distance between each base. So, here's your first vocab word. Your first vocab word is a coordinate plane. Now you should know what this is. A coordinate plane is when you have your x-axis and your y-axis meet at the origin, they intersect, you make four regions, and that is called a coordinate plane. It's the plane that is divided into the four regions. So the next thing we're going to talk about is the midpoint formula. You can find the midpoint of a segment by using the coordinates of its endpoints. You're going to calculate the average of the x-coordinate and the average of the y-coordinates. So, I'm going to start drawing a few things. Now, off to the right, I'm going to start drawing a y-axis and an x-axis, hence making a coordinate plane. I'm going to label my x and my y. Always make sure when you graph, you label x-axis and the y-axis, as well as making sure your axes have lines or arrows at the end. So now what I'm going to do is I'm going to graph two separate points. And I'm just going to make just two random points. A and B. Now if I connect those, I'm going to call its midpoint M. So here's how it looks. The coordinates of point A, even though we don't have numbers, so we're pretending that we don't know any numbers here. The midpoint of A is actually going to be x1, comma y1, because this is going to be the first x value, this is going to be the first y value. B is going to be x sub 2 and y sub 2. That would be the second value of x and the second value of y. Now the midpoint is halfway between A and B. So I'm going to draw a line here to show you what the midpoint formula looks like. The midpoint formula looks like this. You have to find the average of each coordinate. So we're going to take the x values, x sub 1 plus x sub 2, and we're going to take half of that because there are two values. We're going to take both y values, add them together, and divide by 2. That is called the midpoint. Because this right here, I'm going to circle it, this is the average of the x values, this is the average of the y values. So the midpoint formula says this. So here it is. The midpoint M of segment AB with endpoints of A, and then there's the coordinates, and B, coordinates, is found by the midpoint. You find the average of your x values, you find the average of your y values. So let's apply that. Example 1. Find the coordinates of the midpoint of segment CD with endpoints C as -2, -1, and D as 4, 2. Now, we can graph this. We don't need to. All you have to do is plug this into your formula. Here's your x value. Here's your other x value. Here's one of your y values and your other y value. It does not matter which one you let be what. All you do is plug them in. You find the average. So your midpoint is going to be this. Let's start with your x. We're going to take one x value. We're going to add it to the other. And since there's 2, we find the average. We divide by 2. The y values. You take the first y value, add it to the second y value. You divide by 2. So the midpoint then would be 4 minus 2 divided by 2. That gives you 1. And 2 minus 1 is 1, and 1 divided by 2 is 1/2. There's your midpoint. That's it. find the average of both x values, you add them together, divide by 2, add your y values together, divide by 2. Now, you don't need to draw any of this down, but I wanted to show you that if you graph this, C was at -2, -1, D was at 4, 2. If we graphed our midpoint 1.5, you'll notice it's halfway between C and D. All right, so let's look at example 2. M is the midpoint of segment AB. A has the coordinates of 2, 2, and M has the coordinates of 4, -3. Find the coordinates of B. You'll notice in this problem, they actually give you the midpoint, and they give you an endpoint of A. And what they want you to do is find the other endpoint, which is B. So we're going to use the midpoint formula. The midpoint formula says the midpoint is 4, -3. Let me actually make that so it looks like a point. 4, -3. There's your midpoint. Now, this is your x value, this is your y value. So remember what you have to do. Your x value is taking your x values, adding them together, dividing by 2, and that would give you an x value of 4. The y value would be taking a y value, doing the same thing, dividing by 2, and that would give you -3. But wait a minute. We actually have one of the x values and one of the y values. So I'm going to erase the x value and the y value here. Notice right here. A has coordinates of 2 and 2. This is x, this is y. So we know one of them. So let's plug them in. So there's my equation. My first equation is x plus 2, because we don't know one of the x's, but we know the other one. X plus 2 divided by 2 equals 4. So now I multiply both sides by 2. That gives me x plus 2 equals 8. Subtract 2. That gives me an x coordinate of 6. The y plus 2 divided by 2 equals -3. I times by 2. Y plus 2 equals -6. So y equals -8. So my missing coordinate, which is B, would be 6, -8. All you do is you take your midpoint formula, plug in what you know, and then solve for the remaining variables. The next formula you have to know is the distance formula. The distance formula is used to calculate the distance from 2 points in a coordinate plane. Now it's easy when you have something that looks like this. Now you don't need to write this down. Let's say I have a segment here that's A and a segment here that's B, and I want to know the distance from endpoint A to endpoint B. So I want to know the distance of segment AB. Well, that's really easy. You count. It's 4. Because you go 1, 2, 3, 4. This has a distance of 4. That's really not hard because it's a horizontal line. The same thing is be true for a vertical line. However, what happens when you have something that looks like this? What's the distance from this point to this point? Now that's going to be a little different. So we're going to use the distance formula to find that. The distance formula is D equals the squared root of the differences of your x values, your x coordinates, square it, and then you're going to find the differences of your y coordinates, square it, you add them together, and then you take the square root of the entire sum. The 2 points that you're going to use are going to be between the 2 points, x1 sub y1 and x sub 2, y sub 2. So let's use that as an example. Example number 3, we're going to use the distance formula. Find the length of AB and CD. Notice right here that we do not have segment symbols, so that means we need to find the length. Then determine if segment AB is congruent to segment CD. So we first have to find the distance from A to B, which is the length, and the distance from C to D. So let's use the distance formula. So we're going to start with segment AB. So we're going to plug in. Here's x and y, here's x and y. we're going to subtract your x values. So I'm going to plug in 5 minus 0 squared plus, plug in your y values, 1 minus 3 squared. And being that you guys are in tap math, you can skip steps here easily. So we have 5 minus 0 squared, that gives us 25, plus 1 minus 3, that's negative 2 squared, which is 4. So we get the distance as the square root of 29. So now let's find CD. CD, we're going to subtract our x values, so that means we're going to subtract a negative 3 minus a negative 1. We're going to subtract our y values, which is negative 4 minus 1. So right here that becomes plus. So negative 3 plus 1 is negative 2 squared, which is 4. Negative 4, negative 1, that's negative 5 squared, which is 25, which gives me a square root of 29. Therefore, we know, since the length from A to B is equal to the length of C to D, then we can prove that segment AB is congruent to segment CD. And you're done. So remember the distance formula? You use it to find the distance from one endpoint to the next. On example 4, I want you to do this by yourself right now. Pause the video, find the length from A to B. If you did it correctly, you would get either the absolute value of 41, or if you approximated that, it would give you 6 4/10. But I want you to notice there's another way to do this, and it's using what you guys already know from last year. And actually, you might have learned it way back in 6th grade. The first thing I'm going to show you to do is to graph. Now, you don't need to put this in your notes. You can if you want. I'm going to graph both these points. So negative 2, 3, that's A. And 2, negative 2, that's B. So you're probably wondering, well, what in the world? How can I do this differently? Well, you've already learned Pythagorean theorem. I just made myself a right triangle. I know you remember what this is. A squared plus B squared equals C squared. Well, A are your legs. So if you look here, we'll look at our legs. 1, 2, 3, 4. So there's A. 1, 2, 3, 4, 5. There's B, or you can switch them around. So we can plug it in. 4 squared, 16. 5 squared, 25, equals C squared. That gives me 41 equals C squared. I take the square root of both sides, and you end up with the exact same answer. So this is yet another way to do a problem that you've already learned. So you've already learned Pythagorean theorem. You can use Pythagorean theorem. You can use distance formula. Applicational problem number 5. The 4 bases on a baseball field form a square with 90-foot sides. What is the distance of a thrown ball from second base to home? Well, the first thing you can do is you can actually make a rough sketch of a coordinate plane. If you wanted to, you could also use Pythagorean theorem. And you could say, well, this is a base here, this is a base here, this is a base, and this is a base. So what you've made is a square, which is a baseball diamond. So you know there's 90 feet between each one, so this would be the order pair 0, 0. This would be 90, 0, because this is 90 feet between the bases. This is 90, 90. And this would be 0, 90. Now, if you wanted to find a ball thrown from second base to home, you could either use Pythagorean theorem, a squared plus b squared equals c squared, or you can use the distance formula. So we would use this point and this point. So we would take 90, subtract your x values. Well, that's 90 minus 0, which is just 90. So it would be 90 squared plus, subtract your y values, that would also be 90. Simplify, 90 squared is 8100. plus 8,100. That would give us the square root of 16,200, which would give us approximately a distance of 127 or 127.3 feet of the ball thrown from second base to home.